Okay, so in this lecture, we'll talk about some graphs of different types of functions for linear, for quadratic, for cubic, exponential as well. And then we'll talk about a past paper question, which is not exactly that related to it, but basically I wanted to blend two chapters together, right? So let's talk about the graphs. Okay. Some of them would be very easy, and then some would be a bit, I would say, different, right? So let's talk about graphs. We have different types of functions. We have linear, quadratic, cubic. So let's start our discussion with a linear function. So first thing is that what do you understand by linear? Whenever you read the word linear, just know that the power of your variable would be 1, or maybe the highest power would be 1, right? So obviously if the power is 1, the highest power would also be 1. I'll write down a few examples and then we'll see how to plot those graphs. So we have 4 examples for this. Let's say you have an equation y equals 2x plus 1. Then you have an equation y equals 2. Then you have x equals 2. And then you have y equals minus 2x. Okay, so we have 4 different things. Let me make some like sections just so I can plot these over here. Right. Okay. Now we need to understand the plotting. Now, Saneem, you can plot any graph by making a table and just, giving some values for 0. Like you can just find the values this way. This is for X. And then this is for Y. So you can just do it this way, that find the value for y when x is 0, when x is 1, when x is 2, when x is 3, and so on, right? And you would get some specific values for y, and you can just make it, y-axis, x-axis, and just plot. Let's say you have, if we talk about this equation, y equals 2x plus 1. So you can just do it this way, that the value of y when x is 0 would be 1. The value of y when x is 1 would be 3, and so on, right? And you can just make points like this. So it would be 1. This is the point for 0, 1. Then this is for 0, 3, and you can just connect these 2 points to make a straight line, right? So similarly, you can just have any equation in the world. Let's say if you had this, you could have used the same strategy and you could have made the graph as well. But now we are, grown-ups, we need to think about things independently. Yes, there would be some questions in which the examiner would want you to fill in the table and then make the graph, but you should know the general things and basics about this topic, right? Okay. Let's see what would be the graph of y equals 2x plus 1. Always remember, whenever it is linear, whenever the power is 1. All right, now basically, here we are focusing on the power of x, okay? We are focusing on the power of x. We don't care about y. We are only focusing on the power of x. So the power is 1, right? And these are, I'll tell you what exactly it is, but just focus on this equation and this equation. These are 2 typical examples of a linear equation where x has power 1. For example, let's say you had this. What about this? Now the power is 1, but the highest power is 2. So basically, in case of linear equation, the highest power is 1, right? So highest power is 1, okay? Always remember, for linear equations, you get straight lines. Now, those straight lines could be vertical, they could be horizontal, they could be slanting, but they would be straight lines. You won't get any curve for a linear equation. Let's just quickly understand the making of a linear graph. Okay, so these, the first one and the fourth one, they are 2 complicated cases. Let's talk about the simple ones and then we'll talk about those as well. Let me just make the x's quickly for the second one and the third one. Okay. This is the y-axis, this is the x-axis, y-axis, x-axis. 0, 1, 2, 1, 2. I've just roughly allotted some values, 1, 2, and then 1, 2. It says y equals 2. Where is y equals 2? This is y equals 2. So for such graphs, you will just make a line on y equals 2. Now you know that whenever you will make a line on some y value, you would get a horizontal line, right? So you need to understand this thing that whenever you have y equals something, you will get a horizontal line as a result, okay? So the first type is horizontal line, right? Is this okay, Saneem?
Yes, ma'am.
What would be the case for x equals 2? Now, obviously, it is x equals 2. So when you would make a line on x equals 2, it would be not this, it should be on 2. It would be of this type. So it would be a vertical line. So always remember, whenever you have y equals something, you get a horizontal line. Whenever you have x equals something, you get a vertical line. What if you had x equals 1? You would have drawn a line on x equals 1. That's it, a straight vertical line. What if you had y equals minus 1? So you would have just first mention the point y equals minus 1, the coordinate y equals minus 1, and then a line on that. So that would be a horizontal line. Okay. So this is the concept for these two, and this should be clear. So by now, you know, in case of straight lines, you have 4 types: horizontal, vertical, and then you have 2 types of slanting lines. We'll talk about those 2 types. But are you clear with vertical and horizontal lines?
Yes, ma'am.
Okay, very good. So I will just rub this. I need more space for that. So yeah, now let's discuss these 2 things. Y equals minus 2x. And for now, let's just write down y equals x. Now for both of these cases, we are going to get slanting lines, but again, it would be a line. It won't be a curve. And what exactly would it be? Yes, you can think about it by making the table, allotting some x values, then just finding out those points and all that, but that is very time consuming, okay? You should know that this graph, when you are not adding or subtracting something, when you only have y equals x or something multiplied with x, that would be a line passing through origin. Now it would be either this line or it would be this line, right? Obviously, both these lines are passing through origin. How would you know? You would know by the gradient. If the gradient is positive, it would be a slope. It would be an increasing line. It would be a line with that is going upwards, right? So always remember it this way. When your line is going upwards, it would have a positive slope. And when it is coming downwards, it would have a negative slope. By slope, I mean the value that is written next to x. Okay, so don't get confused. It's very simple. Any line that has y equals 3x, or that has y equals 2x, or it has y equals x, y equals 1 by 2x, anything of that type would basically be this line. Okay, the line passing through origin, and it would be increasing line because all these values written next to x are positive. Another concept is this. Let's say this is the line for y equals 1 by 2x. Now I just told you that the coefficient of x is basically the slope. The bigger the coefficient of x, it would be, the steeper the slope would be, right? So what would be happening for this case? Again, our line would be passing through the origin y equals x, the origin 0, 0, but it would be steeper. So this pink line is steeper than the yellow one because the slope is more. It is y equals 2x. Here the slope was 1 by 2. Here the slope is 2. That is why it is steeper, right? So did you understand this?
Yes, ma'am.
Very good. Okay. And I'll quickly talk about this graph. Now for y equals minus 2x, the only difference is, again, it would be a line passing through origin, but it would be of this type. The concept about steepness and all that follows for this as well. Okay. So by now we are done with linear lines. We have 4 types: slanting with positive slope, this one slanting with negative slope, this one coming downwards, then a vertical line and an horizontal line. So we are done with the linear lines. Now let's see what would happen if I add something. Do you know what is going to happen?
I've learned it with the table method.
Okay, yes, you will just make the like you will just give some values to x and then make the points, right? That is good, but you should know this directly as well. Okay, not all of them, but the basic shapes. Okay, so just remember, whenever you are adding one, you can follow the table as well. Your graph will shift 1 unit above. That is it. Okay, and it would be this. Or simply this, simple, just don't get confused. Just remember, now I am talking about the new graph. So this is going to be the value of y when x is 0. Isn't it true? What is happening when x is 0? It is 1 because this would be 0. So when x is 0, we follow the y-axis because this is x equals 0. This is the line for x equals 0, right, Saneem? This line. On this line, I need to focus on the point 1. So my graph will be following through this point. All the other concept is same. It is minus 2. It would be a line coming downwards. That is it. So this would be the graph. That is it. And do you know what would be the coordinate of this point? This line, the line of x-axis, what exactly is the equation of this line? It is a horizontal line. We know that for horizontal lines, it is y equals something. So what is the equation of x-axis? It's y equals 0,
0.
right? Very good. So for finding this point, we just plug in 0 here and we will make x the subject. So what are you going to get for that? Just check the value of x when y is 0 and tell me as well.
1 by 2.
Very good. Okay. So yeah, this is the basic concept. It's okay if you are if you have learned it through tables as well, but you should also know how to, because table method would work for any graph. Okay, right now we're not talking about difficult graphs, we're only talking about the basic ones, so you should know this directly as well. Okay, let's talk about the last example. Let's say we have y equals 3x minus 4. Again, y-axis, x-axis, this is what every graph has, y-axis and x-axis. This would be the value of y when x is 0. When is x 0? X is 0 at y-axis, okay? X is 0 at y-axis. You know that for x equals something, you would get a vertical line and value of x is 0. So this y-axis, the pink line, this pink line is the line for x equals 0. Okay. So when x is 0, the value of y is minus 4. This would get 0 and the value of my y would be minus 4. Now your line would be passing through minus 4. It has a positive slope. 3 is positive, so it would be going upwards. So it would be something of this type, right?
Yes, ma'am.
Are you sure that you have understood this?
Yes, I understand.
And what would be the value of x at this point?
0.
X of x at this point. Okay, x, not y. Y is 0. X is not 0. X is 0 here. Okay, it would be 1, 2, what?
3.
Okay, look. For finding this value, what do we do? At x-axis, what is the equation? At x-axis, y is 0, okay? You will simply plug in 0. What do you get? 0 equals 3x minus 4. So x would be 4 by 3, right?
Okay, yes.
This is 4 by 3. Okay, that is good. Let's talk about the last example because this concept is new, but it is extremely important. And it is very easy as well. So let's say you have minus 1 by 2 x plus 1. Y-axis, x-axis. Plus 1 means what? Plus 1 means that the value of y would be 1. Okay, so simply just do this. This is plus 1. This is y-axis. This is plus 1. Your line would be passing through this point. That is it. Okay, forget about y is 0, x is 0. We are adding something. So it is plus 1. It would be passing through this point. It would be a line of this type because the slope is negative 1 by 2. That is why it is coming downwards. Okay, if we had plus 1 by 2, in that case it would have been this line, right? But since it is negative 1 by 2, so it would be the red line. So did you understand the concept completely?
Yes, ma'am.
Okay, very good. Now let's talk about the quadratic graphs that are very simple. We just talk about two basic things. So for quadratic, you just need to learn two things, a smiling face and a sad face. That is it. So this is the first type. This would be the second type. So either you will have y equals x square, or you will have y equals minus x square. For y equals x square, it would be a smiling face of this type. Okay, not exactly this type. Wait a second. This point is basically passing through the origin. Yeah, okay. Now, obviously, let's say you have plus 1. What would happen? This graph would pass through 1. That is it. This point would be 1. What if you had, this is for this one, for this we have y equals x square. You don't need to understand all the complicated things. I'm just telling you that whenever you will have y equals x square plus something or minus something, it would be a U-shaped graph. Okay, it would be passing through this. At times it would be here as well, it would be here as well, but you don't need to understand when this is going to happen, right? Just remember, whenever the coefficient of x square is positive, right now we have 1, it would be a U-shaped graph. Let's talk about some more examples. Let's say you have y equals 2x square. What would happen? Again, the same graph, okay? What if you had something else? What if you had y equals 2x square plus 1? Again, the same shape, okay? It would be of this type. Just try to follow the concept. Whenever the coefficient of x square is positive, it would be a u. And this u could be here, it could be here, it could be here, it could be anywhere, but it would be a u, right? So are you clear with the basic shape of the quadratic equation y equals x square?
Yes, ma'am.
Okay, very good. Now, the second one is for y equals minus x square. Again, it would be a sad face, okay? So it would be of this type. That is it. It's coming downwards, okay? You know how a sad face is? It's of this type, right? And happy faces of this type. So this is how my drawing is. But yeah. So again, this could be of this type, somewhere here, anywhere. You don't need to understand when it would be that way. For that, you will be using the table method. And in AS, inshallah, you would learn this as well. But for now, just follow the concept. It is downwards because it is minus x squared, okay? So are you clear with the concept?
Yes.
Okay, very good. Now let's talk about the graph of y equals x cube. Okay, now either you will have y equals x cube, or you will have y equals x cube plus 5x, something of that type, right? You just need to understand one thing. Technically, both the shapes are same, but actually they are drawn this way that they look very different. So for y equals x cube, it would be something of this type. And for any other cubic graph, it could be 1, 2, 3. Okay. So both these are the graphs of y equals x cube. Okay. This one could be this way as well. It could be this way as well, right? But just understand the basic shape. One, two, three. Yeah, okay. All right, okay. And then yeah, so this is the basic shape, and you only need to know this much. That is it, okay? Just so if you come across a question, although they for this graph, they won't expect that you will draw it directly. They will give you a table, and some of the values would be given, and you will fill in some of the y values, and then just make the points and then connect them. But still, even for that concept, it's good that you know the underlying shape of x cube, just so if you draw it, you know if you have done it correctly or not, right? Yes, Saneem, is this okay?
Yes, ma'am.
Okay, good. Uh, Now we have the reciprocal graph. Okay, let's say you have the graph of y equals 1 by x. Now in this case, you will get a shape something of this type, and it would be here as well. Okay, this is the y-axis, this is the x-axis. What if you have y equals 1 by x squared? In that case, it would be either this or this, okay? Then what if you have y equals minus 1 by x? It would be of this type or of this type. And then if you have y equals minus 1 by x squared, this is the y-axis, this is the x-axis, and it would be of this type. So the shapes are same, the quadrants are basically being changed, right? Okay. Now, Saneem, you can also understand this by the, what do we call, table method, but you should know the basic shape. For y equals 1 by x, it would be in the first quadrant and in the third quadrant, okay? Then for y equals 1 by x squared, it would be in the first one and in the second one. For this one, it would be in the second and in the fourth one. And then the third one and the fourth one, right? The shape is same, but the quadrants are being changed, right? So you have to remember these shapes, okay?
Okay.
All right. And the last shape is basically for any exponential function. So this is the y-axis and this is the x-axis. And let's say I have y equals 2x or y equals 3x, something of that type. It would be this. And this value is always going to be 1. This is y and this is x. And you can double check that from the table method as well. What is the value of x at this point? This is the y-axis. At y-axis, I told you earlier as well, always remember x is 0. So for finding this value, you will do y equals 2 to the power 0. Anything to the power 0 is 1, right? So this would be the shape for any exponential function. So are you okay with this?
Yes, ma'am.
Okay, very good. Now just give me 1 second. I need to take out a past paper question. So I'll stop sharing the screen and I'll open that and then I'll again share the screen. Okay, I need to stop the recording as well for this.